The most common mistake is to forget this poor little minus 3y dude.
Yeah.
Right? Look when they did that. The whole idea here is, and I want you to realize, the name is perfect. Substitution. Here you have 5 something minus 3 times something else. That sucks. But we know that this must be this. So you plug this in. Right? So there's too many variables. I want to get rid of one of them. One way to do it is to replace it with something about the other variable. Then I've only got one variable. So if I rewrite this, it'll be 5 times x, but x is this.
5 minus 2.
Now for some reason, people always forget this poor little dude. He's got to still be here. 5 times x minus 3y equals negative 14. So just rewrite this, putting that in place of x. Right? Yes. Solve this system using substitution. Oh. Yeah. Or I'll have one of each, and then I might have a problem where it just says solve using the best way. All right. And like somebody already pointed out, substitution sucks. If I could have done one thing to make this suck, if I would have put a 7 there, substitution would have sucked major, because any variable I try to solve for is going to have fractions, right? So if substitution is best when there's one variable at least that has just a 1 coefficient, right?
Okay.
Then substitution is nice.
Wait, what do you do if there is 7?
If there is a 7, we use the other
third
method,
which we haven't
yes,
tested yet.
which we haven't talked about yet, which is coming up soon.
That's in 4.3.
So what do you get here?
25 minus 10y minus 3y equals
Negative 14.
Cool.
Put the
So
left
now
side
it's
together.
just straight up solving an equation, nothing new there.
Okay.
Right? Minus 25, negative 10 minus 3 is
Negative 13.
negative 13y equals
Negative 39.
negative 39, cool. And 13 does go into 39.
3 times.
I like it. Negatives cancel, you get
3.
y equals 3.
And then you plug it in.
The minute you get one variable, that means you can go back and get the other. Right? So I know y is 3, x is 5 minus twice y, and y is 3. So let's plug a 3 in. So somebody tell me, I want to make a point out of this. And if you stop right there, as long as you circle your answers so I can find them, that's good. What should the answer look like? 'Cause the answer should be where these two lines meet, and they meet at a point. So what's the answer? That's the answer. If you just do this and circle it, that's fine also, but I want to make it a point out of the fact that it's a point.
He said if we do one and circle the other, it's fine.
As long as you can find your answer, okay? It should be a point. And just to warn you, your next level class, you might have a teacher who's a little more anal about it, and they want it to be a point always. Just to let you know. But it's fine to get x and y separately, that's fine. But another way to look at it for most of these is it's a point where they meet. All right? So it should be able to be written as a point at the end also. So how do you feel about substitution? It should be.
Love it.
Easier.
And normally people that really hate graphing, they're pretty cool with this kind of thing because they like the algebra a lot better. Yeah.
Much faster.
And what about that? You know, the graph is getting constant. You know that what?
Yes,
What's
exactly.
the question gonna say?
It's going to say solve the system using graphing. Yes. Cool.
And then from there, we graph it, right? Yeah.
You don't need to graph it. You got the
Yeah, this we're done with. If you did graph these lines, where would they meet?
negative 1, 3.
Negative 3, but I don't need to because I've already got the answer.
You graph to find the point.
Yeah.
You got the
In fact, graphing that would suck so bad. If you try to solve this for y, what's going to happen? You're going to get you're going to have 14/3 as a y-intercept, and then count from there your slope several times. No, thank you. So thank God we got algebraic with. Yeah.
We only do it that way when the x equals or y equals something.
Let me show you. Here's the last level of this. Solve using substitution. The only way you know it says that is because I just said that. Solve using substitution. I know. Let's see. Oh, let me do this, sorry.
That's all right. Go ahead.
And I forgot where I was.
Make it easy.
What? I'll be fine.
First you have to get the first one.
Which variable can you solve for directly? And I'm kind of hoping you guys don't notice something, but yeah. What's the only variable that doesn't have a coefficient that's not 1? I mean, the only variable with a coefficient 1 is that guy. I can solve the first one for y then. If I try to solve this one for y or x, I might end up with fractions, right? Because it's something I'm going to have to divide. You might realize you can divide by 2 here, but don't do it. So if I take, I mean, you could, but I don't want to do that yet. If I solve the first one for y, what do you guys get? Minus 1, exactly. If you add the y, subtract the 1, y equals 4x minus 1. And now you just do it the same way we just did a minute ago. Which variable do you want to replace in this one? You're going to plug that into y, exactly. Why wouldn't you plug that back up here? If you plug that back here, how many pieces of information have you used? You're plugging that here. You're plugging that into itself, right? You're going to get something like 0 equals 0. You're going to get freaked out. But you have to use both of these. If you get one, plug it into the other one. So then you're using both pieces of information. So what do you give? You write 2 now. Plug this in for y. Negative 6x minus twice 4x minus 1. So I'm just rewriting this whole thing. Negative 6x minus twice y, but y is this, equals negative 12. And now you just solve that. You got one variable in there. Yeah.
Why is that a negative 1 and not positive?
If you subtract 4x and divide by negative 1, that'll become a minus 1. Right? Yeah. You got to move it to the other side, or you got to divide by negative.
Wouldn't it be negative 4 though?
Okay. So if I do 4x minus y equals 1, if I add y, subtract 1, that's what I always do. If the y is negative, I just add it to the other side, makes it positive. That's a quicker way to do it. You could subtract 4x, divide by a negative. The negative would cancel, make it positive 4. And the 1 and the negative 1 would become negative 1. All right? Okay.
No.
That kind of thing, real quick, guys, if you're still having trouble solving something like this for y, I'm not going to take all that much time. That should be something we can do. I might do it a different way than you do, but we should all end up with the same answer. That should be an easy thing to do, right? Solve this for y. So what do you guys get here?
Minus 14.
Cool. So you get minus 14x, subtracted 2. X is 1. Right? And then y is 4 times x minus 1. So y must be 4 times 1 minus 1. Y is 3.
Nice. So amazing.
Right? You guys see that? Once you get one variable, you can plug it back. You can actually plug it back any of these equations. But whenever you do substitution, you're always going to have one that's already solved for the other variable. Right? That's a good one to plug it in. If I put it into this one, you'd still get the same answer, just be a little bit more work. Okay. I got that impression. What's the answer then here, really? And that's fine if you stop there, but what's the answer? 1, 3. I love it. Cool. That's the point where these would meet if you graph them. Cool, man. I don't hear that phrase much with systems of equations, but I like them too. So here's the last.
But I'm not going to like them if they all have numbers.
Here we go. Here's what we do if they all have numbers in front of them.
Shooting straight through into that hunch.
You're taking everything.
Are we still in 4-1? Are we in 4-2 now? 4-2.
4-1 was graphing.
4-2 substitution.
4-2 is substitution.
And now we're going to
4-3 is the third method. There used to be one section because they all do the same thing. What do? They all solve a system of equations. But this book decided to break it up into 3 sections.
Yeah,
I know, right?
Jam.
correct it.
That's right.
All this homework, man.
So I'm always joking whenever somebody sees me grading somewhere. I'm like, if I just would assign less homework.
Yeah.
I don't think my students would be upset, and it'd be easier on me, but
Yeah.
I'm just crazy that way.
That's it.
You grade every single problem.
Yeah.
3 classes.
So section 4.3, it's called, I think the book calls it the addition method, but that's just stupid. It's called the elimination method. Oh, cool. It calls it elimination. Sweet. The book we had before called it addition method. That's stupid. Elimination method does exactly what it says it does. It kills one of the variables. Right? Section 4.3, page 264.
Elimination method.
Zoom it along.
This is method.
Yep, the elimination method. Thank you. Exactly. Cool. So here's the idea. If I have, let me start off with one that we could actually do substitution, but I want to make it nice just to get into this. And then we'll see the uglier types. Oh, don't make it too hard on yourself, Jeff.
That's a 5. Not an S.
It's a 5, yeah. There's not 3 variables up there. Now you made me forget what I was doing. Okay, there. Doesn't take much. Now, sometimes students will accept what I'm about to do and not even realize that they should actually sort of be troubled by it in a way. Because it is a little weird. If I add 4 to this, what must I add to the other side? I must also add 4. Well, what is 4? Isn't 4 equal to this? So if I add 4 to this side, I can add this to this side. Because they're both 4, aren't they? Doesn't it say 4 is this?
Yeah.
So that's why you actually shouldn't have a problem with the fact that I can add equations directly together. I can't, because I really am adding the same thing to both sides, because that is 4. Okay, so I just want to make sure you guys understand. There is a slight thing where you should be a little bit troubled, but not really. If I add these directly together, what's so cool about that?
You eliminate the Y.
My problem is, I like that. The problem with either one of these alone is they both have 2 freaking variables. That sucks. But if I add them together, the fact, because these y's are opposite signs with the same coefficient, right? They both have a 1 coefficient. Just one is negative, the other one is plus. So when I add them together, of course, these eliminate. Now be careful. I always have somebody say this on the next line. Where'd that come from? That's not right. Don't write that down. Do you see where that came from, though? They said, and I kind of feel funny saying this to them because it's kind of evil, but I'm like, you can't just take this equation close and then the y goes away. You know, it's not like it's popping a bubble or something. You're actually adding them together. So what do you get here?
3x.
3x. So be careful about that. I want to make a point of that. The y doesn't just suddenly magically disappear. You actually have to add these together. 3x, negative y plus y is 0.
Equals 9.
9.
X equals 3.
Then you make it opposite signs. This is the next level. We'll get there. Now this is my favorite method. I always do elimination whenever I do these kind of problems. The one little thing that students don't like is there's no equation solved for y, but it's the same thing. You can pick either one you want and plug the 3 in for x and solve for y. So which one do you want to do? Second one. I agree with you because it's nicer, right? Doesn't matter. It really doesn't matter. You should get the same answer both ways. But if I take the second one and put a 3 in for x, what do I get for y?
1.
What's better? I know, I don't. Yeah, you should actually be able to step back from algebra and just say, of course it's a freaking 1. 3 plus what is 4? Well, it's 1.
Right.
So realize that. I appreciate that you realize that. That's fine. There's nothing wrong with that. Not if you're doing it too much, I might. In places where it should be a little harder to do it. I got to see some work. But if you just do that like right there, not a problem. I love it. So what's the answer then?
It's a 3-1.
I like it. And again, if you don't do that, if you do this, it's fine. It's fine. This way. So I took the second equation, and here I solved for x, didn't I? What's x? So instead of putting an x there, what am I going to put there? 3.
Yeah.
And then solve for 1. Subtract 3, y is 1. If I do it in the other one, twice 3 minus y equals 5, 6 minus y equals 5. Y's got to be 1, right?
Gotta be.
Oh, yeah.
Same answer both ways. It's got to be. That's a way to check yourself. Cool. I like that. So somebody had a question, and it's not just because you have this question, it's because we have to do this. They're not all going to be that nice. I mean, that was really nice because it was set up, the y's would cancel. They're not always going to be set up so they will automatically cancel. Gorgeous. Westman.
So
All right.
grab me with these nothing.
Stay with me now. Excuse me. So if I have something like this instead, let's see. Let's not make it too heavy. What? I don't know.
7.
It's 7. It's 7 out of you.
Again, the instructions here would say use elimination. So I know some of you guys might realize, isn't this a good one for substitution also, if you're allowed to do it either way? What variable would you solve for if you could do substitution?
1.
Because it's already having 1, right? So it's easy. So the instructions say, no, you must use elimination, right? What's wrong with trying to use elimination directly the way it is? What? Does any variable go away if I add them right now?
No.
So never do that. Somebody always does, they add them together, they're like, where do I go from there? I'm like, well, nothing went away. Don't do that to yourself. Don't add these if nothing's going to go away. What do you wish was there?
2.
How do you make a 2 show up there? Don't. Beautiful. You multiply this equation by 2. You can't just put a 2 there. I don't like that problem. Let me make a different problem. Because they're already opposite signs though, right? So this one I just, now watch what I do for myself. 1 I'm going to leave alone. 2, now this is where a little bit of the bookkeeping gets in people's way sometimes. We said we're going to multiply 2 by 2, right? So 2 times the second one, I'm going to write that there. Some of you guys aren't going to do this, I understand, but it's nice to kind of be able to tell yourself what the hell you did. When you look back at your homework, you're going to be like, what the hell is that? So tell yourself, I did twice 2. What do you get when you double this? 4x plus 2y equals negative 10. Right?
Is it negative times negative?
No, we're multiplying by 2, not negative 2. I don't need to multiply negative. They're already opposite signs, right? I just want a positive 2 right there. How are we doing?
Good.
And you see that because the whole idea is I want a letter to go the hell away. So I have to match them up. Opposite signs, same number, so that they will go away.
Is it always best to keep it in the order that the book has it? Instead of like, say, how we just did the, that, we put the 2 in, and then we put the first one on the bottom of the second one.
Oh, it doesn't matter.
Doesn't matter?
Either way I add them, this is going to cancel, right? Yeah, as long as you keep number 1, 1, and number 2, 2, you're fine. You could have turned these around. Is that
So
what you're
then we
saying?
get a positive 1 instead of negative, or no, we get 7. Or no? Are we adding those up?
Yes, we add them up.
Oh, okay.
Yeah. Right. You never subtract these because then the negatives are hard to keep track of. You always make them opposite signs so you can add them. So here you get 7x. Those cancel. Negative 2. Yes, sir.
You plug it in.
No, of course not, right?
You got this negative.
Does it matter where I plug that negative 2 now to get the y? Which one am I going to do it in? Number 2, because y is almost alone already, right? But it doesn't matter. Because they have to both be the same point, right? Okay. So when I plug this in,
Do we have to, when we plug it in, when we plug that 2 back in, do we plug it back into the same equation that was there, or the new equation that we made up?
either way. Yeah, Jeff, You could plug it in here also. That's the same equation as that. These are the same exact equation. You guys with me on that?
We're gonna get the same answer?
Equations are the same if they have the same answer. This is just twice this one. They're the same thing. So if you did plug it in there, you could do that, but that's you don't want to plug it into that one because the coefficients are going to be bigger than they have to be, right? You plug it into one of the original ones normally. Cool. So what do you get here? You get -4, add 4, y is -1. Cool.
That's what I
So the answer is,
got. See?
Wait.
what's up?
We put in
How come?
-2 for
Did you put it in the first equation?
x.
No, I did it on the second.
Yeah, so if you do it in for x, it's right there, right?
We
So how come we don't go back to
Here?
that one? Yeah.
You could. Jeff just asked that.
Okay.
All 3 of these. And it's not really 3 equations up here. There's only 2. This is just double that one. These 2 have to be the same, don't they?
Yeah.
So it doesn't matter which one you plug it into. In fact, you can plug it into that one if you want to also.
Wait, is that
But I got
four
-9.
or what?
Well, that's a problem. Let's see. So if I do it in here, 4 times -2, I get -8. And here's the problem. Add 8. Right? Well, there's your problem.
Oh.
Yeah, yeah. Not subtract and get 18. So see, it doesn't matter. I get the same answer, don't I?
Yeah. I just.
It doesn't matter. I wouldn't do that because it's, bigger coefficients than you need. Just plug it back into one of the original ones. If you have time, plug it in the other one too, just to see if you get the same number. You're supposed to.
It's not a quiz day.
How are we doing on that? Good. Yeah.
Good to go.
Good to go, not quite.
All right.
But it's out early every day.
So here is the highest level of this, right? You know, algebra always likes to build on itself.
Let's do it.
Here's the worst that an elimination problem can look like. Let's say
That's 7.
Isn't it with 3?
what do I say now?
So we want to get the x is the same. For number, doesn't matter, right?
Don't say anything for a second.
Yeah, hold on. He's got to figure out what it equals.
Yes. 5.
There. I want this to work. It'll probably be good.
Wait. Question.
Yes, ma'am.
Isn't there like ones where you do like this third steps and a third?
Yeah, remember now. How many unknowns do we have in these 2 equations? 2. So how many equations do I need? 2. If I had x, y, z in an equation,
So there's 3.
I would need 3. Right? Okay. Now, what is really wrong with this? I mean, yeah. In fact, it's the same idea as LCD. It's exactly the same process as LCD. Some people would pick these because they're smaller than, but I would pick these because they're already opposite signs, right?
Right.
You're not going to make a negative mistake when you try to change all the signs. So what's the LCD between 6 and 5? 30. Now, do you guys understand why it's an LCD idea? I need to make these the same number. Isn't that exactly what I do with a fraction? I want to make the bottoms the same number.
You can do the same thing with y and hit by 14, right?
Exactly, except one of them you got to multiply by -2 maybe and 7. Right? Because they have to be opposite signs, don't they?
Yeah.
The 2 numbers have to cancel, so they have to be opposite signs.
Right. So you got to times.
These
both
are
of them.
already opposite signs. So it really doesn't matter. I mean, you can multiply this by -2 and this by 7.
Right.
And one will be -14 and it'll be 14. But then you open it up for making a negative mistake somewhere. Right? Yes, sir.
So you have to times both of them then.
Exactly.
Yeah.
Yeah.
So that's why it's like an LCD idea. Right?
This is the ugliest it gets, right?
This is the ugliest it gets.
Alright.
So what would I multiply the first one by?
5.
By 5. So what do you get? -10. And if you want to I wouldn't suggest you put a little 5 in there because when you come back to plug stuff in, it might throw you off. But if you have any trouble, you can actually just go ahead and write, have an intermediate step where you have 5 times 6x plus 5 times 7y equals 5 times -2, so you can get these numbers more directly. If you have any trouble thinking about it in your head as you put it down.
6 times 4
multiply by -5, right? By 5. They're already opposite signs, aren't they? Aren't they already opposite signs?
So why put 30x? Why did you put -36?
I didn't. I put 30x.
No, what's 6 times 14?
94.
So what do you multiply the second one by?
Really?
6.
Nope, 47. Wait,
So
no.
what's -5 times 6?
I did it right.
What's -5 times 6?
60.
-30. 2 times 6? 12. -14 times 6? Careful. -14 times 6? 0.1. Yeah.
Negative 94.
84, right? Yeah.
84.
Remember what I said. This is the ugliest problem you'll see with this. Yeah.
Why is
Why
74
is
24?
the first one is positive 5 even though we instead of a negative 5?
All right. So
Because
what I wrote
get the
here,
second part.
what I wrote here
Right.
is showing you what I did from here. What did I multiply the first one by? 5.
But why not negative 5 since negative 5?
They're already different signs. Don't I want them to be different signs so that they'll cancel? I want them to be different signs so that they will cancel. If they were both 30, that would make 60. I want no x's. I want the x's to die, right?
I get the bottom part. I get the second half.
So let's go back.
I don't get
Somebody remind me.
how you multiply.
What was the first problem we did? I can't. Somebody remind me. The first elimination problem we did, real quick.
First elimination was 2x minus y equals 5.
Oh, I'm sorry. Hold on. 2x minus y.
Yeah, equals 5.
And-
X plus y equals 4.
Now, were you cool with what we did here? What did
Yeah,
we do
that
there?
was an easy one because you
No, no, no.
cancel
I
out
want you
the-
to notice how there's nothing different here.
Well,
Why does it make sense to add them together right now?
When you add which one? The
Why
y?
does it make sense to add those two equations together?
Because the y cancels out.
Because they're different signs.
Right.
So I better have different signs on my 30s or else they ain't going to cancel, right?
Oh, you have to make them cancel.
Different signs. That's why I wanted to use these two. Why? Because they're already different signs.
Multiply the equations, it seems
The numbers change. Yeah, yeah, yeah. Because when you multiply, you just change the coefficients. Yeah. So you guys, all right, let's finish this out, and then I'll show you what would happen if you wanted to do it with the y's. Cool? We'll see what happens that way.
So it's 94 divided by
What do you get here?
plus the other -10.
And then 47 goes into -94, -2. Because twice 47 is 94, and there's a negative. Oh, I'm sorry. There's a y, -2. Okay, sorry. Why? Because once you get what y is, how do you get what x is?
Plug it in.
Plug it in. So if I take like equation 2, -5x, as I want to. Y is -2, I plug that in. So we get -5x minus 4 equals -14. Add 4, I get -5x equals -10. Divide by -5, I get x is 2. So you should get 2 -2, right? Real quick, let's do this again. In fact, you guys do this problem again, but this time make the y's disappear first. Of course, you should get the same answer, but try to do it so the y's will cancel first. Call me over if you need to know.
Wait, so
I
I'm
just
plugging in,
wrote it all wrong.
Wow.
I'm plugging in the y now. What do I, that's the step I'm on. Plugging in the y.
I plugged the -2 in here,
That's what I'm doing now.
so I'm right there, see?
Oh, okay. Let's see.
And then you just solve for x. Two -2. Because you divide by -5, the negatives cancel.
So you want to us to do what? You want us to do that same problem?
That'll do it. So
Do
you
that same problem, but get rid of the
do this same problem, but this time kill the y's first.
X equals 2, right?
Yes.
Damn.
No, I didn't. I'm doing half this one and half that.
Oh, I do.
Oh my god. That's my biggest thing.
That'll never work.
I was gonna remember the LCD. That's like the next one.
So let me real quick make sure the first step is going okay.
It's gonna be in the text.
What's that?
It's gonna be in the
Hey, one
text.
is,
Oh, yeah.
one is negative.
Yeah. Why is -2?
Just make sure everybody's doing the right first step. It really doesn't matter which one you change a sign, but you all see you have to change the sign somewhere. If they're both 14, they'll be 28. So if you take the first one and multiply by 2, I like it. That'll be 12x plus 14y equals. Then you better multiply the second one by -7. Because otherwise you get 14 and 14 is 28. The y's don't die. I want them to die. So times -7, what do you get now?
35.
35x
Minus 14.
minus 14y.
What is that?
Sorry, what's up?
You choose the 14 is that's easy?
Yeah, 7 and 2 has a 14, right?
It's -7 times -14.
It's positive.
Positive, yeah, positive. Yeah. Thank you.
So you can actually do it both for the X or the Y, right?
Yeah.
Yeah, exactly. You just normally do whichever one's easier.
Yeah.
Right?
Sure.
So what do you get there? These die, thank God.
Right.
If you ever add them and and both letters are still there, erase everything you just did because you did something wrong. You want a letter to go away because there's too many of them. So what do you get here? And that looks familiar. That's all actually kind of like what we got over there for y. So divide by 47. X is 2. So far, are we looking good? Same thing we got over there, thank God, right?
Yeah.
And now that you got 2 for x, you can plug it into either one of these and solve for y. Right, so I can plug that 2 back in. Let's say I plug it back into this guy. -5 times 2, because x is 2. Plus 2y equals 14, negative. Add 10. Divide by 2, y is -2. Thank God. 2, -2, just like we got before.
So your calculus is doing similar stuff like this is harder.
They're doing things with equations of planes, not just lines. So, yeah.
But it's the same concept, though, right?
Same concept.
So they still have to do all the same methods we're doing. It's just one more, probably a bunch of stuff. Right?
Yeah, basically. It's the same concept. It doesn't look quite the same because we use different symbols for different things. So, yeah. But on one level, I want you guys to realize everything you're learning right now is valid throughout all of math. I mean, it doesn't suddenly change. You don't go into math and say, well, now forget everything you learned in 90 because this is all crap now. You know, everything I'm telling you now is true for all of math, and it's normally order operations that kill some of my higher level students that forget, you know, which level to do it. I'm like, shit, if you just knew that, you'd be better.
And what's actually math 128? I know 103 is algebra, intermediate, right?
Yeah.
And then 120 is just what, a higher level of algebra?
120's kick-ass math. I love that course because it's math where I teach Egyptian hieroglyphic numbers. I teach Fibonacci sequence. If anybody's ever heard of Fibonacci sequence.
Okay, this
Really?
So we have to learn these numbers and the different numbers.
Yeah, it's awesome.
Don't you use like words? That's what I'm doing.
I like it.
Like use them?
Use words.
Okay, that's cool. That's
What's up? Really, I am.
Right.
I don't believe you.
How long did it take you to come?
All right, guys.
Wait,
Just make sure everybody understands what we just did. We got through up to 4-3. 4-3 is elimination method, right?
Yes.
Stop there.
Yeah, definitely. Brain
Section 4.4, just to say real quick, we're not going to do 4.4, but just to let you know, 4.4 are the. Well, let me do this. I'll do one more example with you, and then we'll head out. Right? And everybody got a practice test, right?
Yeah.
Yeah.
If you didn't get a practice test, make sure to pick one up on the way out. Right? On the way out.
Is this an example out of 4.4 or is this 1.4?
Let's find out.
Yeah, great. I just want to know where to write it.
4 hot dogs and 3 orders of fries.
Sam Stark.
Cost
Freezing bushes.
$11.50. 2 hot dogs and 1 order of fries. Cost. Oh, what did I say up there? $5.50.
Oh, we can times it by.
I'll tell you, it's 4.4.
He's going to tell us.
It's 4.4, but I'm not going to make 4.4 due. Don't worry. So up through 4.3 is due next Wednesday, right?
Yeah.
I just want to show you a little preview, just to show you how these word problems are a hell of a lot easier than the ones we did earlier. Let's see if you agree with me. So the question here would be, what does one of each cost? So these equations really set themselves up much better than the ones we had earlier where we had to set them up, right? So, what does one of each cost? Yeah, what's a 1 hot dog cost and what's 1 fry cost?
We can do eliminations.
Say again?
We can do eliminations.
Oh, hell yeah. Once you get the equation set up. So these equations, again, they set themselves up. What are my 2 unknowns? Yeah, so let's call hot dogs, let's not call it H maybe. Well, H will be fine, if we're cool with that. And fries we'll call F. Yeah?
Right.
That's amazing. So what's one equation I can set up from right here? 4H plus 3F equals 1150. All right, that's equation number 1. What's equation 2? 2 hot dogs plus 1 fry is 550. Now from here, these are the kind of problems where I'd say solve, and it's up to you to figure out how to solve it. And you can do it any way you want to. So if you wanted to, you could do a substitution. That'd be easy, right? Solve for F, plug it in here. Elimination would be pretty easy, wouldn't it?
Yeah.
Multiply this one by
2.
-2. So they'll be opposite signs, right? Either way you want to do it.
I was going to say, could you just do the bottom one multiplied by 2?
Yeah, you can multiply by -3. Either way, right? So if I do this, let's do elimination because that's the way I like better. 4H. So leave this guy alone. What would I multiply this one by then? You want to do -3?
Yeah.
Why not? So multiply by -3 if you want to. You could multiply by -2. I don't care. So if I multiply by -3, I'll get -6H. Oops. Minus 3F equals, now what's -3 times 550? 1650. -1650. See now what's going to cancel when you add those together? Yes. Good. Right. If only that was that easy. So there they go. And then 4H minus 6H. -2H. 1150 minus 1650.
-5.
$5, right? Negative.
Yeah.
I didn't mean to make it come out to, oh well, it's too bad for me. So H would be what? 250. That's what it looks like. Somebody did all that right.
Jeff,
Yes.
how about if you want to solve it with a substitution?
Sure. Then you would solve for F, right? You would subtract 2H, cool? You can subtract 2H there if you want to. And then you would plug this in here for f, right? You want to do it by substitution, right? Is that what you said? So solve for f, and then plug it back in here. Plug that there, right? You get one variable by itself, and the only one that I can get by itself easily is f, right? It's got a 1 coefficient, so just subtract the 2h over. I'll take that and plug it in place of f up there. That's substitution method.
What just happened?
Somebody asked me, what would it look like for the substitution method?
Oh.
Solve it for f, plug that in for f. Right? Because now you know f is this, plug it in place of f, go to 10.
Right.
Real quick, if h is 250, 250. You plug it back in, you get solve for fries, right?
That's actually, I like it, the word problem. That's like the first time I would say I like word problems better than that's the man there instead of every point.
Yeah, this is relatively easy, right? Definitely better than the other word problems. But just make it clear, you only have to do homework up through 4-3 for next Wednesday. On Monday, I'll have the answer key for the practice test. And grab one if you didn't get one. The quiz correction?
Fries for 50 cents, really?
Yeah. Quiz corrections, test corrections due Wednesday. By the day of the next test also. Oh. Oh, you need your... Oh, yeah.
Okay, thank you.
What's this? Oh. I haven't graded that yet. Come on. Yeah, I graded that. And maybe... Yes. Good. Yeah.
Cool. Jeff?
Yeah.
I did all the homework. I only missed one, just one. Don't tell me no finish. I always do.
Alright, you only missed one.
Only one.
And everything else is your work. Is your good.
And one thing, did you talk to the financial my problem?